Hello everyone. Welcome back to Dr. Lou's VCE Physics channel. Today, let's learn together about the NHT 2023 physics examination. We will focus on questions related to gravitation and planet motion. My explanations may need to be revised. If any teachers, parents, or classmates find errors, please feel free to provide your guidance. Calculate the ratio of two gravitational forces. These two satellites have the same mass, but S1 has an orbital radius of 5r. The gravitational force is in inverse proportion to the square of radius. If the radius increases to 5 times, the gravitational force will decrease to 125, a square of 5, not 1/5. So, A is correct. Here, it does not need to calculate the value of gravitational actually, the ratio is enough. Calculate the gravitational force between Enceladus and Saturn. Before calculation, please read the answers. There is a huge different order of magnitude among these four answers. We only calculate the order of magnitude, not the actual force's value. So, D is correct. Ask the ratio of the Sun's gravitational force on the Moon and Earth's gravitational force on the Moon, not the actual value of forces. So, it is unnecessary to refer to the value of their mass and distance, and the ratios are enough to answer this question. Here, it is known that the ratio of the Sun's mass to Earth, the ratio of the distance from the Sun to the Moon, and the distance from the Earth to the Moon. We express these forces as gravitational equations, then, divide Fs by Phi. The mass of the Moon is cancelled, and the ratio is converted to the function of the Sun and Earth. So, we express the mass of the Sun as the times of the mass of the Earth, and the distance of the Sun to the Moon as the distance as times of Sun to Earth. Finally, we calculate the value of the ratio. The centripetal acceleration is equal to the gravitational acceleration or strength of gravitation. So, we use the universal equation to calculate the centripetal acceleration. The distance between the Earth and the satellite is the distance to the center of the Earth, not altitude, so we should add the radius of the Earth onto the altitude of the satellite. Of course, the acceleration is towards the center of Earth. Please note units. km should be converted into meters. Please note that y-axial is force, not strength of gravitational field. So, the area under the graph is the energy required to lift this satellite. Counting squares is okay, but too slow. The shape is near a trapezoid. We calculate the area of this trapezoid and get the answer. Or, gravitational energy is a potential energy, which is determined by the altitude of mass. We can calculate the GPE at 500 and 1,400 kilometers, respectively. Then, the energy required is the difference between these two values. Please note that x-axial is km, the value of altitude should be converted to the meter by the fact 1000. The final result must be expressed as joule in 3 significant figures. Please use the scientific notation, not draw 0. The delta GP is a little bit smaller than the area of the trapezoid because the area under the trapezoid is bigger than the area under the graph. Two multiple-choice questions worth 2 marks, and 2 short-answer questions worth 8 marks in gravitation and planet motion. The overall score for this section is 10 points. With a total possible score of 130 points, the percentage for this section is 7.7% of the total score. If you need my help, please add me on WeChat or WhatsApp, and send me an email. Thanks for your attention. Please note Dr. Lou's VCE Physics channel and Lou's VCE Chemistry channel.